Good day to all. In this lecture, we are going to see on fiber fineness. And in fiber fineness, we will see the introduction to fiber fineness, various terms related to fiber fineness, and airflow method will be explained in this lecture. So, from this picture, can you identify who's a fine person? Yes, you are right. The left side person is a fine person and the right side person is a fat person or a coarse person. Similarly, if consider these two as two fibers, can you identify which is a fine fiber? Yes, you are right. The left side is a fine fiber and the right side is a coarse fiber. So, hope you understand the term fineness. So, it is nothing but weight by length. A ratio of weight and length is your fineness. So, the left side fiber is of less weight for the same length. Both are of same length. The left side, the weight of the left side fiber is less. So, it is a fine fiber. Whereas the fiber on the right side is of having more weight for the same length. So it is a coarse fiber. Hope you understand what is a fine and a coarse fiber from this representation. Next, this fineness so is expressed in weight per unit length. So weight by length is fineness. So it is expressed as weight per unit length. Like microgram per inch, gram per 10,000 meters, gram per 9,000 meters. Similarly, it is expressed. So weight by length is also called as linear density. So fineness and linear density means the same. Fineness or linear density means weight per unit length. The weight and the length terms differ according to the terminologies. So linear density and fineness both are one and the same. So what is this linear density? Why the term linear density? Density means mass by volume. Mass by length is linear density. Density mass by volume, whereas only the linear form is taken. Only the length is taken. So it is called as linear density. So it is a terminology to express fiber fineness. Why do we measure fiber fineness? When it is a pen tip or a pencil tip, we measure in terms of diameter. But for fiber, we do not measure it in terms of diameter. Why is it so? So it is because the fibers are not circular always. You can see our cotton fibers are bean shaped, and you can see wool fibers, the cross section is irregular. Silk fibers is triangular in cross section. Flax fibers, some hexagon type of cross section is there. Acetate, an irregular outer layer is there, and for rayon also some outer layer is not circular, so it is irregular in shape. So this irregularity, if diameter can be measured when it is a circular one, when it is uniform. When you measure, say, the red color line and the green color line, blue color line here, so if you measure it as diameter, which you will see as diameter, it is different in different areas. You can see it has diameter ranging from the blue line length to the red line length for each of the cross sections. This is one reason why we do not go for diameter measurement in fibers. Another reason is it is not of uniform cross section. You can see the along the length, I have marked the different red color lines, and you can see along the length there is the variation throughout the length, and the cross section is also not uniform. It is not circular. The cross section is not uniform throughout its length, and it varies throughout its length. So These are the reasons for measuring the not measuring the diameter and measurement of linear density. So the difficulties in the measurement of diameter leads us to the measurement of linear density, which is mass by length. Uh, but does this linear density tell about the diameter? Is there any relationship between the linear density and diameter? So can linear density be used as a measure of fiber fineness or linear density? Is it correct that we go for linear density instead of measuring diameter? Because in all other cases, they will measure diameter. In mechanicals, when it is tube or when it is a pen tip or when it is a wire, when it is anything else, you measure the diameter. All mechanical instruments, the vernier caliper or things are there to measure the diameter. Whereas here we use linear density. Is it a correct measure? Let us find the relationship. So to find that relationship, let us assume the fiber to be circular, and you assume the fiber length is L and the cross-sectional area is A. The blue color is the cross-sectional area and the fiber is of length L. So the volume of the fiber is area into length. So it is considered as a cylinder. So volume is equal to area into mass is equal to volume into density. From the relationship, the density is equal to mass by volume. We have rewritten as mass is equal to volume into density. Volume is equal to area into length. From the picture, we have already written that. So instead of volume, we are writing it as cross-sectional area into length into density. Mass is equal to cross-sectional area A into length L into density. Bringing the length to the left hand side, we get mass by length is equal to cross-sectional area into density. So from this, we know that mass by length is proportional to cross-sectional area if the density is constant, and mass by length is nothing but your linear density. Hence, linear density is proportional to cross-sectional area. So it is there is nothing wrong in measuring linear density instead of cross-sectional area. Let us go into the various terms that denote fiber fineness or fiber linear density. So first and the foremost important term used for cotton fiber fineness measurement is micronair. So micronair is one term telling about the fiber fineness, especially cotton fiber fineness. Everywhere, micronair is the common terminology used. Micronair is the weight in micrograms present in 1 inch of fiber. We will not take 1 inch of fiber and weigh it. If you weigh it, you will get it right. But a bunch is taken, and some indirect means are used for measuring the weight and length. So this is nothing but the ratio of the mass in micrograms and length in inches, in 1 inch. So it is the weight in micrograms present in 1 inch of fiber. So it is an important terminology used for cotton fiber fineness measurement. Most of the instruments measuring cotton fiber fineness will tell the results in micronair or microgram per inch. Next important terminology is decitex. Decitex is equal to the ratio of mass in grams and length in 10 kilometers. It is nothing but the weight of the fiber. Uh, when you take a length of 10 kilometers and weigh, what is the weight you get out of it in grams is called as decitex. This is also a common terminology used for measuring synthetic fiber fineness. So usually when you mix synthetic and cotton fibers, you check whether when you blend it, both the fineness are nearby. So you usually convert it into micronair value and check. So the conversion factor for converting from decitex to micronair is 0.394. Next terminology and important terminology commonly used in synthetic fiber fineness is denier. Denier is the ratio of mass in grams and length in 9 kilometers. Denier is used in commonly synthetic fibers are sold in the measurement of denier. So the length and denier are the two things that they will specify for a given fiber length. So this and denier also can be converted into micronair value by multiplying it by 2.82. Next is TEX. TEX is also a measure of fiber fineness, but it is a common term used for yarn linear density, yarn length by weight. Commonly, TEX is not used for fibers, but is in rare cases when the fiber is very coarser, new fibers, when it is like as monofilament, they use TEX. TEX is the ratio of mass in grams and length in a kilometer. That is, if you take 1 kilometer of fiber and weigh it, the value you get in grams is called as TEX. It is used for yarn linear density commonly. Next, let us go on to the various methods of determining fiber fineness. The basic method is and simple method is gravimetric method, and the standards are ASTM D157701. This is used for cotton and wool, and you take 100 fibers and weigh it, cut it to a specific length and weigh it using a micro balance. So that is gravimetric method. Next is the microscopic method. For when the fibers are circular in cross section, you can measure the diameter and convert it into fiber fineness. Next is optical method. Optical methods are also used commonly for circular fibers, uh, wherein the fiber diameter is measured by some method, and the other different methods for light scattering are also used in determination of fiber fineness. Next, an important method and commonly used method of fiber fineness for synthetic fibers is vibroscope method, wherein a vibration principle is used. You keep the fibers in between two jaws and you pass in some frequency, and when the passed frequency is in tune with the natural frequency of vibration of the material, then you get resonance, and from that they identify the linear density of the fiber, and this is common for synthetic fibers. And next, and the most important method for measurement of fiber fineness of for cotton fibers especially, are used is airflow method. Airflow common method for determining fiber fineness or micronair value. Airflow method gives the micronair value or microgram per inch, and it ranges between 2 to 5.5 to a maximum for cotton fibers. So, in this lecture, we will look into the details of the airflow method, how airflow, the principle behind that instrument is airflow, how airflow is used in determining fiber fineness. So this is an indirect method. It is not a direct method. Gravimetric method is a direct method. You measure length and weight, then it is direct method. Here, the length and weight are not measured directly, but it is measured in an indirect manner, and you find the micronair value. This is a very simple instrument. You just put in the fibers, open the fibers, put in the fibers, and you get readings in a very short time. So this is a preferable method and commonly used in various mills and also in test centers. So let us look into how the determination of fiber fineness is done using airflow method, or an instrument which follows the airflow principle. So the aim of the experiment is to determine the fiber fineness of the given cotton fiber sample by airflow method. Next, these are the related standards to measure fiber fineness. The method which is explained here is based on the IS standards and ASTM standards number given here. So the measurement is done for determining fiber fineness of cotton fiber, and the unit is microgram per inch. Micronair means microgram per inch. So the principle, the airflow is different for fine and coarse fibers. The difference in airflow through fine and coarse fibers is used in the measurement. The airflow is actually inversely proportional to the specific surface area of the fiber. So airflow and specific surface of the area of the fiber are inversely proportional. Airflow is inversely proportional to, yes, the specific surface area of the fiber, not specific area, specific surface area of the fiber. So what is this specific surface area? Specific surface area is defined as the ratio of surface area to volume. Surface of area of the fiber divided by volume of the fiber. Let us look into the notations. Specific surface area S is equal to surface area divided by volume. Surface area is nothing but your perimeter into length. Perimeter is 2 pi r or pi d. So it is written here as pi d into L. Surface area pi d into L. At a particular point, pi d, throughout the length of the surface is measured. So it is pi d into L. Volume is pi r square into L. So pi r square is the area, or pi d square by 4 is the area into length is your volume. So solving for this, the pi dl and in the denominator pi d and l gets cut and you get 4 by d. The 4 goes to the numerator. So specific surface area is equal to 4 by d, or specific surface area is inversely proportional to the diameter. Specific surface area is inversely proportional to the diameter. We already know that airflow is inversely proportional to specific surface area, and in turn specific surface area is inversely proportional to diameter. Hence we get airflow is directly proportional to diameter. Hence for diameter measurement we use airflow, or we use airflow to measure the linear density of the fiber. So when the diameter is high, there will be more airflow, and when the diameter is less, there will be less airflow. This can be viewed in this picture. Airflow principle. There are two cylinders A and B. Left side A cylinder which has coarse fibers, and on the right side cylinder B with fine fibers, packed with fine fibers. Air is passed through, equal volume of air is passed through A and B. Equal volume of air passing through A and B. The air coming out of A is higher and air coming out of B is coarse, is less. You can see from the picture, the air coming out of A is higher. Coarser fibers is higher, finer fibers is lesser. So this is airflow principle. Airflow is directly proportional to diameter. The same is represented in the picture. You have two cylinders. Cylinder on the left is packed with fine fibers and on the right is packed with coarse fibers. Equal volume of air. So the number of arrow marks at the bottom is given the same, and on the top, when air passes in to both of these cylinders, and when air comes out, more air comes out where coarse fibers are there, and less air comes out when there are fine fibers. Another picture representing the same is this one. Fine fibers on the left hand side and coarse fibers on the right hand side. less air coming out of fine fibers and more air coming out of coarse fibers. This is how the airflow principle is represented. So the principle behind the determination of fiber fineness, the method is airflow. The principle behind the instrument, airflow instrument, is what was explained in the video, and hence the instrument measures the rate of airflow under controlled conditions. The specific surface of area of the fiber is determined. By measuring the rate of airflow, you can determine the specific surface area of the fiber and consequently the fiber diameter or the fiber mass per unit length or fiber fineness. Hence, the fiber fineness is measured using airflow method, a very simple method of measurement. In the next lecture, the instrument description and procedure can be viewed. Thank you.